Hello, my name is Grace Gaikwad, and this is my Data Intensive Scalable Systems project on spatio-temporal analytics of global GPS interference and navigation disruption. The aim of this project is to build a fully automated big data pipeline that ingests multiple related data sets, processes them in Spark, stores the outputs in a database, and presents the results through follow-up analysis and interactive visualization. This project uses three complementary sources: a GPS interference dataset, an aviation safety reporting datasets, and the gpsjam.org interference feed. These datasets are related because they describe navigation disruption from different viewpoints. When real files are missing, the system can generate realistic synthetic data so that the full workflow still runs end to end. This configuration file controls the whole system. It defines storage locations, database settings, synthetic data parameters, clustering thresholds, model settings, and benchmark sizes. This is important because it keeps the pipeline reproducible and avoids hard-coded values. Automation entry point. It runs the complete pipeline in one control flow: ingestion, Spark processing, clustering, predictive modeling, follow-up SQL analysis, benchmarking, and hotspot map generation. That means the project is not a collection of disconnected tasks. It is one integrated workflow from raw data to final outputs. Perspective, the raw data is staged in blob storage using Amazon S3 semantics. Spark reads that data programmatically through the S3A connector, transforms it in a distributed environment, writes proceed packet outputs back to storage, and pushes the analytical summaries directly into PostgreSQL. This satisfies the key project requirements for blob storage, distributed processing, and direct database persistence. You can download the CSV datasets. I will now move to the overview dashboard, which represents the main analytical results. The dashboard is interactive and supports filtering by region and source, interference type, severity, and date range. The Overview tab answers the first research question: where and when the interference events cluster. The density map clearly highlights major hotspots, especially the Eastern Mediterranean, the Black Sea, and the Persian Gulf. The daily time series chart shows temporal fluctuations, while the calendar heat map shows when activity is most concentrated during the week and across the day. Distribution tab. The distribution tab gives a deeper breakdown by region, source, and severity. For clustering, the project uses both dbScan and HDBScan. dbScan recovers 7 major dense clusters, while HDBScan found additional structure in regions with variable density. Using both algorithms make the spatial analysis more robust because not all interference patterns have the same shape or intensity. Is predictive modeling. The project trains random forest, gradient boosting, and LSTM models. The first two are used for severity classification, and the LSTM is used for short horizon forecasting. The reported results show about 0.70 classification accuracy and useful forecasting error levels. This tab also shows benchmark outputs, demonstrating that the Spark pipeline scales effectively as data volume increases. Strategy and risk tab. After the distributed processing stage, the project performs a follow-up SQL analysis by building a regional risk index. This combines event volume, severity, duration, and cluster behavior into a single composite score that makes the final output more decision-oriented than raw counts alone, and directly addresses the requirements for follow-up analysis on store results. As you can see, the full pipeline is still running. The success of the running of full pipeline. This is through where you can download the CSV datasets. In addition to the dashboard, the project produces a standalone hotspot map. This is useful for offline presentation and review, and it visually confirms the same high-risk region identified by the clustering, modeling, and SQL analysis. To conclude, this project delivers a complete data-intensive solution: multiple source ingestion, blob storage, distributed Spark processing, direct database writing, clustering, predictive modeling, benchmarking, follow-up analysis, and interactive visualization. The main findings show that the GPS interference is strongly concentrated in a small number of geopolitical hotspots, that predictive models can provide useful operational insights, and that a database-driven regional risk index supports clearer decision-making. Thank you for watching. I will now run the full pipeline